Finding normal probabilities. Let's look at some examples of calculating probabilities on normal distribution. Let's say the weights of newborn babies in the U.S. are approximately normally distributed, mean 74, standard deviation 1.1. Let's find the probability of a random baby in the U.S. being born weighing exactly 7.6 pounds. Remember, probability is supposed to be area under the curve from your starting point to your ending point. Well, we have no starting and ending point. We only have a single point, and so we have no area, so the probability is 0. This can be a little disconcerting at first, because with discrete probability distributions, we said probability equals 0 means that the event cannot happen. That's no longer the case with continuous distributions. It is possible that a baby could be born weighing exactly 7.6 pounds, but because that's one out of infinitely many things that could happen, by classical probability that would be 0, because this is 1 over infinity essentially. So for a continuous probability distribution, not just normal, but any continuous distribution, the probability of your variable equaling a given value is always 0. So how about something with a range? What's the probability of a baby being born weighing more than 9 pounds? Well, let's look at our graph a second. We'd like to go from 9 to infinity, but in most software or calculators you're going to use, there's no infinity. So you want it to be a number way out in that tail on the right. The rule of thumb I've been using is 10 standard deviations above the mean. So we could do that. So what's the mean? 7.4 pounds. What's 10 standard deviations? Well, 1.1 times 10 would be 11. So 11 pounds plus 7.4 pounds would be 18.4. So we could go from 9 to 18.4, roughly 7%. If we return to our graph, think about where 18.4 is going to be on that graph. So even though that graph goes on forever, we are so far out there that any bit that we're leaving off is inconsequential. How about a baby being born between 7.6 and 9 pounds? Well, we have a high and a low value here, so that's easy. Just go from 7.6 to 9, about 35.5%. If we return to our graph, you see 7.6 to 9 would be most of that chunk on the right of the mean, so that percentage, 36%, seems reasonable. What about a baby being born weighing less than 5 pounds? This is similar to the greater than 9 example, except for this time it's a less than. So we want to go from negative infinity up to 5. Again, we don't have a negative infinity button, so just go down 10 standard deviations. So 7.4 minus 11. And so negative 3.6 up to 5 gives us about 1.5%. Again, let's just make sense of this from our graph. We're being asked for a probability of less than 5. That's way far out there in that left tail. And so very little out there in that end part of the tail. When you're working these problems, I recommend making a rough sketch just like this picture. Put your mean in the middle, count up 3 standard deviations and down 3 standard deviations, and then draw your bell curve so that covers most of the visible area. Then when you're getting your answers, you can make sense of whether what you're getting from the technology seems reasonable based on your picture. So make a graph and shade the area. It'll also help you become more familiar with the distribution itself. It's good practice.